You're watching the Weiss channel. Today I'm going to talk to you about even and odd functions. Okay? Determine whether this function is even, odd, or neither. Okay? F of x equals 1 minus 9x squared plus 8x to the 6th. Okay? So what you're going to do is you're going to put in negative x instead of x. And if these two match, it's even, okay? If I put in negative x, all right, notice I will get negative 9 times negative x to the second and 8 times negative x to the sixth. Does it make sense that negative x to the second will still come out to be x to the second, because negative times a negative is a positive? In fact, whenever you have an even exponent, right, a negative x will come out positive, right? Because negative times a negative is a positive. So note that f of x equals 1 minus 9x squared plus 8x to the sixth. F of negative x also equals 1 minus 9x squared plus 8x to the sixth. That is even. That is an even function. Okay. Here, f of x equals negative x to the 7th plus 4x to the 3rd plus 5x to the 5th. If you put in f of negative x, all right, when you have an odd exponent, right, negative x to the 7th, like that, will come out as negative x to the 7th. Negative x to the 3rd power will be negative x to the 3rd power. Negative x to the 5th power will be negative x to the 5th power. So you wind up with negative makes positive x to the 7th, minus 4x to the 3rd, minus 5x to the 5th. Okay? So now that's the opposite of f of x. F of x is minus x to the 7th plus 4x to the 3rd plus 5x to the 5th, whereas f of negative x would be positive x to the 7th minus 4x to the 3rd minus 5x to the 5th. So now we test the negative of all of f of x. And when you take the negative of f of x, that means you just change all the signs. Change that sign, and that sign. So when we do that, you see that f of negative x matches negative f of x. If that happens, it's odd. Okay? So when f of negative x equals negative f of x, the function is odd. Over here, f of x equals negative x to the 3rd minus x minus 3. F of negative x would give me positive x to the 3rd plus x, but also minus 3. Right? Here's minus 3 and here's minus 3. So notice that when I do negative f of x, I get positive x to the 3rd plus x and plus 3, and thus these two do not match. Nor do these two. So if these two don't match and these two don't match, it's going to be neither. The little shortcut should be for you that if you notice, like here, if you're going to have even exponents, right, chances are it's going to wind up being an even function. If you have odd exponents, chances are it's probably going to be an odd function. Just make sure notice that all the terms have an x value, okay? And notice here, all right, there's odd exponents, but here there's no x after the 3. That means, all right, it won't flip when you do f of negative x, because when you're doing f of negative x, it winds up flipping because of that negative, but there's no x value after the 3, meaning that's going to stay the same. So when you have a number all by itself like that, it's probably going to be neither. Okay? Now, what about graphs? This is really, really easy. Okay? here's the y-axis. If your function reflects across the y-axis, it's even, which hopefully makes sense because look here. 1 gives you a value of -4. -1 gives you a value of -4. That's even. 5 gives you a value of 0. -5 gives you a value of 0. That's even. This is an even function. Okay. Over here, this one is odd because if I can flip it and it's the same thing, flip it, it's the same thing, that's odd. Okay? In fact, that should also make sense because look, 2 gives you 2, but -2 gives you -2, the opposite. Look, 7 gives you a result of 2, but -7 gives you a result of -2. That's odd, basically the opposite, okay? Here is neither, because it does not reflect across the y-axis, and I can't flip this over and make it be the same function. So this one is neither. You've been watching the Weiss channel.